Hello, everybody. Yes, I'm doing the second day on on that same Sunday. I just got through with the bike ride. Yes, my hair is still yucky. However, day two of this stuff, it's a little bit trickier today because we're going to add some other stuff in. Yesterday, when we were doing our domain and range, we were doing discrete data only, meaning this is data that when you look at a graph is only individual dots. And that way I was just listing individual X numbers and individual Y numbers. Today, we're going to look at data that's called continuous. Now you can recognize from a graph if it's continuous or discrete, because if it's just individual dots, it's discrete. If, on the other hand, you have some dots, but maybe they're joined by lines, like a parabola or a line with arrows on either ends, you do not have to have arrows for it to be continuous, okay? As long if it stops right there at that dot and stops right there at that dot, we want all these little points in between the dots. That is continuous, okay? So continuous just means you have solid lines drawn between the dots. You don't have to have arrows, okay? But continuous data, and you may say, well, when we're going to talk more about when it's discrete and when it's continuous. When you look at the graph, it's easy to pick it out. Later on, you're going to have to determine from a situation which you're going to, if you're the person making the graph, which you want it to be, discrete or continuous. And we'll talk more about that. But discrete things are things like tickets. I can sell one ticket or two tickets, but I can't sell the 1.5 or 1 3/4 or 1.98 part of a ticket, right? So I just have a dot for one ticket, a dot for two tickets, a dot for four tickets over here, right? So that's why when the data is things that you would count, like tickets and dogs and cars and things like that, things that you would not chop up into little bitty fractions. Things that you would chop up into fractions are things that you measure, like feet and time, seconds, hours, degrees in an oven, things like that. So things that you measure, you tend to use as continuous data, and things that you count tend to be discrete data with individual points. And we will practice that a lot more, but today we're going to focus on the domain and range of these and just picking out if it's discrete or continuous by looking at the graph. So let's look at this first one up here. We want to find the domain and range. We want to find whether it's continuous or discrete. So let's do discrete or continuous first. So on your paper, you just have to write number one, and you can either write discrete or continuous, and you can put a D or a C for this first part. Do I have just individual dots up here, or do I have lines drawn between these points? So which one is it, discrete or continuous? And I think the D, discrete for dots. Discrete dots. Does this have just individual dots? No, this is continuous. So this one I would write continuous. Okay. Now, domain and range is a little bit trickier when it's continuous data. I am still looking on the domain for X numbers only. I'm focused on this X axis here. And what I do when I don't have just individual dots, I bring it in and I crop the picture to right here and here. I never go to the left of this point. I never go to the right of this point. So I look up here and find those two numbers and circle them. I have a -6 and I've got a +2. All of these points that are on this graph, if I bring them down to the x-axis, there's a point there, I can bring it up to the x-axis, bring it up to the x-axis, up, all these points can come down to the x-axis. I am using all these numbers on the x-axis. All these points are being used on the x-axis, but I never go to the right of 2 and I never go to the left of -6. So all I did was crop it down to all of my x's are literally between -6 and 2. And that's what there's too many for me to list them individually. There's millions of numbers in here if I do all the teeny tiny little fractions and decimals in between there. Too many to list. I wouldn't want to list them all. So instead, I'm going to make it into an inequality. What goes in the middle? This is domain, so it better be the X in the middle. If they will have an answer on the answer sheet with Y in the middle, and everything else will be correct, but they'll put a Y in there. And if you're doing the domain, don't pick that answer, okay? You want the answer with X's in it. Domain are your X numbers. Okay, the number on the left is a -6, the number on the right is a 2. As long as you set it up this way with the small number on the left and the big number on the right and the X in the middle, you will always turn the inequality symbol pointed to the left on both of those. My X's are bigger than the -6, they're this way, and my X's are smaller than the 2, which is over here. So it will always be set up this way. Now, the only last thing you have to talk about is whether there's a line underneath your inequality symbol or not. Remember, let's see if we can turn this over this way. Remember when we're doing our inequalities, if there was no line, it's an open circle, and if it's equal to it, there will be a solid there. So these little points on the end are solid. So if they're solid, then that means -6 is included, so I'm going to draw a line underneath it. It's also equal to -6. Since this one was also solid, I'm going to put a line underneath it. Now, for right now, if you can pick out that x goes in the middle and you have a -6 and a 2, you're doing fantastic. Okay, that's really all we're trying to get today is the two numbers on either side and the x's in the middle. Okay, so there's the domain range. Now we need the range. That's my y numbers. So y numbers now are the up and down numbers. So this time I'm going to crop it along the y-axis. What's the highest point it goes to? What's the lowest point it goes to? And the lowest point is a -6, and the highest point is 3. So all of these y numbers on this graph, if I were to take them over to the x-axis or over to the y-axis, all of these numbers are being used all up and down in here. All of my y numbers are going up, and all of these little points are going over to a y number. I never use any of the y numbers above 3. I don't use any y numbers below -6. So my y's are between those two numbers. So my y goes in the middle, my smallest number goes on the left, the biggest number goes on the right. And as long as I set it up that way, I'm always going to turn the arrow to the left, okay? Does it need a line underneath them? This is a solid point, so that -6 should have a line. And up here at the top, it's solid up there. They did not put an open like this coming up there, right? There's no open circle up here. It's solid. So since it's solid, I'm going to put a line underneath that one too. All right, so if you can get the -6 and the 3 and the y, because on a multiple choice test, you're just picking this answer out. As long as you can visually pick it out, you're okay. We're going to try to practice writing them by hand, totally from scratch, but it makes it easier when you get around to the multiple choice test. Okay, now this one, is it discrete or continuous? It's a table, and how many points are listed here? 1 point, 2 points, 3 points, 4 points. So if I were to graph this, I've got 4 individual points on a graph. So it's 4 individual dots, D for discrete, so this is discrete data. And domain and range are easy on discrete data because I'm literally just listing the x numbers that are being used and the y numbers being used. This is like yesterday. So domain, big old swoopy symbol. My x numbers are smallest to biggest, 1, 2, 3, 4. Oh, wasn't that nice? They put them in order for me already. 1, 2, 3, 4. Commas between them, right? Range are the y numbers. So I put a big Y here to remind myself I'm looking for the y's. And f of x is your y, so it's, oh, look at that. There's only one number being used, because I only list it one time. The range is the set whose members are a -3, and that is it. It's the only thing in the set. That's the only y number being used in that graph. Okay? So discrete data is much easier to do the domain and range because you're just listing the individual numbers. When it's continuous, you're mostly going to have an x in the middle or a y in the middle, and you have 2 end positions. Not always the case, but we'll see some of those that are not in just a second. Okay, smooth this up and do 3 and 4. Because this is a really tricky thing to do on the continuous, I will do most of this worksheet with you, but if you got it and want to put it on pause and try to work a few and then come back and see how you did, you've obviously got the answer key to check them against too. Now this individual ones, but number 4 is kind of a tricky one because you need to put it in a calculator and look at that picture. So let me turn this back around here straight. There we go. All right, so number 3, let me slide this up a little bit. Let's see if we can get 3 and 4 up here. Okay, so these are individual dots. So is that discrete or continuous? Individual dots. Dots start with a D. This is discrete. So on your paper, number 3, you need to write discrete, or D for discrete. And then for domain, you're going to write set symbols. Since it's individual dots, I want the individual x numbers. So if I come up here, this is 2, that's a -2, 3, 4, 5, -6. So I'm using -6, -2, that one's a -6, this one's a -2. This one's right at 0. This one's at 1, 2, 3, 4, 5, 6, 7, 8. On the x-axis, I'm using 8, 9, and 10. So those are the x numbers. If I take this one up to the x-axis, bring that one down to the x-axis, that one's on the, right there at the y-axis, right there where it intersects. That point is coming up to a +8, this point's coming down to a +10. So all I did was just circle those numbers along the x-axis that are being used. So those are my x numbers. And again, you could have made a table and just put the ordered pairs for each of these points. So my smallest numbers are -6, -2, 0, 8, and 10. Oops, that's not a pretty swoopy. Mr. Peterson, my algebra teacher, would be upset if I didn't make a pretty swoopy. He had us practice that all the time. And he had made us practice say, the set whose members are. That's the way he would say it. The set whose members are. So every time I see those symbols, that's what I hear in my head. The set whose members are. Now you're going to be stuck hearing that. Yep, sorry. Range, y numbers, right? Domain was x's, range of the y numbers. So my range is the y numbers. So now I'm going to take all these points over to the y-axis. That's a 7, that's a 6, This one's on 4.5. This one's on 4. This one's coming over to 0, right? Yeah. Oh, was that a 0 on this one? Oh, I may have done those totally all wrong on the first one. I don't know. We'll come back and look at I'm going to look at the domain again here in just a second. I may come back and do the domain again because I didn't even notice that the X was down here. I think I'm still right on my counting. Yeah, I'm pretty sure it was. -6. I will come back and look at this second. Range. My lowest number was a 0, and then 4, and 4.5, and 6, and 7. There we go. Let me check my X's real quick. So I had a negative. Ooh, yeah, my X's were totally off here. I had a negative. I think I missed that point altogether when I was looking at this. Or did I? No, I did. 1, 2, 3, 4, 5, 6. Yeah, that was -6. Oh, you know what? They're counting every other line, aren't they? Ooh, so my numbers are totally wrong. I just realized that. They have a 1/2 and 1, 1.5, 2. So all of my numbers are completely wrong on that one. So if you're looking at me like, Mrs. Harris, you're not paying attention. You were right. I was not paying attention on that one. So, domain, X's. I have got a point at -3, -1, 0, and then I've got one over here at 4, and I've got one at 5. So those are my X numbers. I have a -3, -1, 0, 4, and a 5. I totally missed that they were counting every other line. And then on the Y's, let's go back and look at the Y's again now. That means this is 0, so this is at 0. This one's at 4. That one's still 4.5. I think I'm still okay on these. This is 6 and that's 7. So my Y's I think I had okay. The range, the Y numbers were 0, 4, 4.5, 6, and 7. There we go. That looks better. Okay, so domain and range. Be sure and pay attention to how they're numbering the lines, because if they're not counting a single number for each line, then you've got to look to see what they're doing. Are they counting by 2s or counting by 1/2s? All right, this one. It is a equation. If I want to do this domain and range, I need a picture. So how are we going to get a picture? Yep, put it in your graphing calculator. So go to Desmos.com, type in the equation y = 1/2x - 4, hit enter, and it's going to make you some sort of a lovely line. It's going to look something like this. It's going to do this, right? It's a line. Now, it doesn't have arrows in your picture, but it does keep going forever and ever, right? So this one's slightly different. So I'm going to put my x-axis along here. Here's my x-axis, right? So I don't know where this was crossing, but here's my x-axis. So this point's being used, so all these points are being used. When I come in from the side to crop this thing, instead of having a dead end right there, it keeps going. So this line is going to keep going forever and ever. So if I go all the way out here to x's being way out 1 million or so, will that line still be above me? Yes, and so I'm using all those x's. So since this has an arrow going that way forever and ever, or my x is going to go that way forever and ever. Yeah. And then the line's going to the left and down, but is it going to keep going left forever and ever and ever? Yes. Am I going to use all these x's out here forever and ever? Yes. So the easiest way to say this is I want to use every single number. So the domain becomes, I can put this up here, domain. I'll put it right here. Here's my domain for my x numbers. These are all real numbers. It's the set of all real numbers. Remember our all real number symbol? They could also do it with an infinity symbol. They could even say positive infinity and negative infinity, meaning it's going both positive and negative, both directions. So they will say something to the effect that the domain is all real numbers, okay? Because I'm using them in both directions forever and ever. So now let's look at the range. So we had this lovely line, and now we're going to look at the y numbers. So this is my y-axis. So wherever it was crossing on the y-axis, is this line going to go up forever and ever? Because if I crop it down, I hit an arrow. So as soon as you hit arrows, you take your hand and it goes, it keeps going that way. So it's going to go up forever and ever, which means that my y is going to go up forever and ever? Yes. This line is going to go down forever and ever. So am I using all these y numbers going down forever and ever? Yes. So since it's going up and going down forever and ever, my range is also all real numbers. Okay? Or the infinity symbol with a plus and minus. So they could say it in a variety of ways. But basically, you need to be able to say, tell me it's all real numbers inside the little set symbols, right? Okay, so there's that one. And now, is this continuous or discrete? Was it a solid piece here? It's not individual dots, right? So since it's solid, this was continuous. All right, so make sure you tell me continuous or discrete, and then give me the domain and the range. All right, let's try number 5 and 6. If you think you got it, pause the video, you go work them. Check your answers with the answer key if you need to. Well, definitely check them with the answer key, because you want to make sure you're getting them right. Okay, so discrete or continuous first. It's not individual dots, so this is continuous. It's solid through here. There's solid pieces. I want all these little numbers between -1 and -2. I want all the little numbers between 1 and 2. I want all those little pieces in between there. Continuous. Domain. Those are my X numbers. So if I come in from the sides, I hit an arrow. It goes that way forever. I hit an arrow, it's going to go left forever. So since it's going left and right forever, my domain is all real numbers. We'll put that inside those set symbols. Range, Y numbers. I hit an arrow, so it's going to go up forever, it's going to go down forever. So all real numbers again. There we go. So all real numbers, all my Y numbers are going to be used. None of them are excluded. They're all being used at some point. Again, we have a lovely equation. If I'm going to do domain and range and tell me if it's discrete or continuous, I need a picture. So put it in the calculator, Desmos calculator, go type it in, see what it looks like. It goes right down the y-axis, and I think this is a +1 on the y-axis. So it's right here at 1, and it shows you this, but it does have arrows, okay? So it's doing that. So since this is a solid piece of line being graphed there, right? I don't want to call it a line, but it's a solid curve or whatever. It's not individual dots. So this is continuous. Okay, domain, X numbers. So focus on this X-axis here. If I come in from the sides, does it stop here with dots or does they have arrows? They've got arrows. So this one's going to go right, very slowly right, but it's going to keep going right forever and ever. So all my X's keep going. Arrow on this side is going out slightly, so it's going to keep going left forever and ever. So again, all of my X's are being used left and right. So my range, no, domain, I had it right the first time, domain is all real numbers. Now range on this one is not all real numbers. So just because one is all real numbers does not mean the other one's going to be. You got to look and see. So when I bring my hands in on the y-axis to see what's happening, I get to here and I have arrows here. So yes, it does go down forever. I want all those y numbers going down. But does it ever go above 1? No, it never goes up here. So I just want all the numbers from 1 down, okay? So this time, I've got my y, if you want to put the y first. Are my y's bigger or smaller than that one? Do they go above, which is bigger, or do they go below? They're smaller. So all my y's are smaller than 1. Is it solid there at the top? Yes, it is. So I'm going to have a line underneath it. So I want all the y's less than 1. I want all these y numbers down here forever and ever. And that should make sense when you write that. So my range, you can put this inside set symbols. Usually they'll put it inside set symbols. Sometimes they get carried away and they forget to do set symbols. But the more formal definition of where you have to do this would be set symbols. Okay, so there's that. Let's go on and look at the next page. If you got it again, go work your problems and check your answers. If you need more help, I will work these with you today. Just because the continuous ones are really tricky, especially with those trying to decide with the arrows what they should be doing. Number 7. Okay, first of all, continuous or discrete? Yes, this is continuous. You can see those solid pieces of curve there. So this is continuous. It is not individual dots. So my domain are the X numbers. So come in from the sides. And when I come in from the sides, it stops right here at -3. I'll put a big -3 there. And it stops right here at +3. So all of these X numbers are being used all through here. All my graph is between these two numbers. I never have any part of the graph that goes to the right of 3. No part of that graph goes to the left of -3. So they're all between those two numbers. And domain are my X numbers, right? So the X's are literally between those two numbers. So X, -3, +3. As long as I put the small one on the left and the big one on the right, which way do I turn the arrow? Point it left. Point it left. Now, did this one have a solid circle? So the -3 should have a line underneath it. This one is an open circle, so should there be a line underneath that one? No. And this is where the answers on the A, B, C, D answer choices get really tricky, because you got to double check which one. They may put the line into this one and not here, so don't pick that answer choice if they flip them the other way. They will have everything right, but put the lines in the wrong position. There'll be an answer further down that will be correct. There will be a correct answer on there. You just got to be sure you double check it, make sure you have it right. Range, Y numbers, the up and down numbers. So if I come in from the top, I'm going to stop it right there at 9. It ends right there. There's no arrow. If If I come in from the bottom, I'm not looking at this point over here. I want the very bottom of the graph. The very bottom, this is where a mistake is made, because a lot of you would want to just look at the points. This is the bottom of the graph right here at -2. So this is the bottom. I'm going to go to the very, very bottom of my graph. And I'm using all these y numbers between those two, 9 and -2. And again, these are y's. So it better be a y in the middle, my small number on the left, the big number on the right, point it left, point it left. On the -2, is it solid right there? Yes, there's no big open circle there, so this is a line underneath it. And then on the 9 up here, that's an open circle, so that one does not have a line in it. But as long as you can pick out the numbers right now, and if the y's are between them, that's fantastic. If you can start picking out whether it needs a line or not, even better. Okay, tomorrow we're going to practice this again some more. Okay, number 8, discrete or continuous. Well, that's 1 point, that's a point, that's a point, that's a point. So it looks like I've got 4 points on a graph. And if it's 4 individual points on a graph, there's nothing that tells us they're connecting them. So as far as we know, it is discrete. So my domain are the x numbers. I'm just going to list them in order from smallest to biggest. -2.5. I've got 3. It's used twice. I only need to list it once. And a 4. So again, you only list the domain and range once, even if they're used more than once. Right? Range, it's my y numbers. X's were first, y's were always second. Just like in the table, I have a 2, a 3, and a 4. And I will close that up that way, right? There we go. Domain and range. See, the discrete ones are really easy. The continuous ones are the ones that you got to really think and stop and look at. Okay, here we go again. Domain and range. First of all, is it discrete or continuous? It's solid, kind of a line drawn, right? It's solid curve or solid line, so this is continuous. It is not just simply dots. Domain are my x numbers. So again, come in from the sides. When I come in from the sides, I'm thinking, oh, it's going to stop right here, but no, those are arrows. So those arrows keep going up and out. So they're going to go left and right forever. So all real numbers. Range. Y numbers this way. So along the y-axis, I come in from this side. It never goes below this number, does it? And that's a 3. Up here, though, I hit arrows, so it's going to go up forever. So my y's are all the numbers bigger than 3. All my y's are bigger than 3. So put your y, put your 3, and then I'm going to put, the y's are bigger, so I'm going to eat that way. Was it solid here, or was it an open circle? It was solid, so make it a line underneath it. So all my y's are greater than or equal to 3. Okay, number 10, discrete or continuous? Yep, it's a table of just, 5 individual points, so this is discrete. These are the easy ones like yesterday. So my domain, x numbers, list them in order from smallest to biggest. 2.2. Oh, I think they list them in order in the table. That's nice. 4.0. I'm just going to put 4 and 6.2. Okay, so there's my x. And then, of course, the y's, you're going to list the y numbers, right? Don't need to list them more than once, so they're only going to have a 0 got listed, a 1 got listed, and 2 got used. So I just list them one time. Domain and range. Okay? So again, stop this anytime you want and go work some of the worksheet and come back and check and see how you're doing. I'm here to walk you through it if you need it. Otherwise, go work the worksheet and check your answers. But if you need some more help or need some more practice, I am here for you. Okay. Let's see, number 11 and 12. Last 2 on this, and then I'm going to turn you loose on the third worksheet. Discrete or continuous? Yes, these are individual dots. This is discrete. Domain are my x numbers. So if you take these up to the x-axis, this is -1.5. This one is at 0. This one's here at 1.5. And this number is 3. So I'm just going to list those individuals. I just took each dot to the x-axis and looked to see what the number is on the x-axis that they're on. So set symbols, I have a -1.5, smallest to biggest, 0, 1.5, and 3. And close my set symbols. My range are the y numbers. So now I'm not going to look at the x's, I'm going to look at the y-axis. I'm going to take the points over to the y-axis. There's a 3, there's a 1, -1. I'm going to put -1 out here beside so we can see it. And -3. So I have -3, -1, 1, and +3. So smallest to biggest, -3, -1, 1, and 3. I think I got all my points on there. 1, 2, 3, 4. 1, 2, 3, 4. Yep. Last one, number 12. Discrete or continuous? Yes, this one is continuous. You see this solid piece. I want all the little numbers in between. I just don't have that point and I don't have that point. I want all these little points in between. So that's what makes it continuous. Oops. Can't spell continuous. O-U-S. Oh, I thought that looked bad. Continuous. There we go. Domain, X numbers. So come in from the sides. This is my X-axis, right? So I follow the X-axis in and look for where I first hit the graph. And it doesn't have dots there, it's got arrows. So the arrows means it's going to go right forever and ever and left forever and ever as it's going down, but it does go left and right forever and ever. So I want all real numbers. My range. Just because my X's are all real numbers does not mean my range will be. If I come in from the top, it stops right there. It never goes above -2. But when I come in from the bottom, it does have arrows. It's going to go down forever and ever. So I want all the y's less than -2. So put your y first. Put your -2 beside it, and since my y's are smaller, I'm going to put the point toward it. Is it solid up there at the top, where the -2 is? Yes, it is. So all my y's are less than or equal to a -2. Okay, I told you this day's a little bit trickier. It's not bad once you get the hang of it, and it's going to take a few days to get the hang of the continuous ones. So give the third worksheet a try, see what you come up with, check it against the answer key. Okay, that's why it's there, so that you can check it to see what you're doing right, what you're doing wrong. You want to know that before test day. Okay. All right, guys. I will see y'all tomorrow.